All right, today we're going to be looking at solving radical equations. So there's a couple of different versions of these. In general, what you want to do is you want to isolate the radical. So it could be a square root, it could be a cube root, but you want to get that by itself, and then you can get rid of the radical and work on finish solving your equation. Okay, so 51, let's start with that one. And the first thing you want to do is you want to get the radical isolated. So I'm going to move the 9 to the right side. So you're just going to add 9 to both sides. And it is cube root of x equals 8. Okay, so to undo that cube root, we are going to cube both sides of our equation. So the exponent of 3 undoes that cube root, and so we get x equals 8 cubed, or x equals 512. Okay, on 52, on this one, we're going to square both sides first. So the square cancels out the square root. You have x plus 25 equals 16. Then move your 25 to the right side, and x equals -9. Okay, now look at the difference between 51 and 52. On 51, that 9 was outside of the radical, so that's why we moved the 9 first. But on 52, the 25 was underneath the radical, so we had to get rid of the radical before we could get into that 25 and move it. Okay, so for 53, the first thing you're going to do is you're going to divide by 2, kind of get rid of that coefficient in front of the radical. So you now have a cube root of x minus 3 equals 2. So to cancel out that cube root, we're going to cube both sides. We get x minus 3 equals 8. Add 3. And x equals 11. Okay, so that is solving if you have a radical. Could be a cube root, square root, fourth root, just whatever power you need to counteract that radical, that's what you're going to use. Okay, now with 54 and these next set of equations, these are going back to the rational roots that we had talked about earlier in the chapter. Okay, let me back up here for just a second, and I want to show you something. Okay, back up at this statement right here, cube root of x equals 8. Yeah, cube root of x equals 8. All right, so we took both sides to an exponent of 3 to get rid of that cube root. If you remember back to rational exponents, your cube root could be written as a 1/3 power. So the cube root of x and x to the 1/3 power, those are the same thing. Okay, so if on this one, I cube both sides, like I did when it was written as a root, you have a power to a power. So x to the 1/3 to the 3rd power, if I multiply power to a power, multiply exponents. So multiply 1/3 times 3, you get x equals, and then 8 cubed is 512. Okay, so you can solve that equation either from how it originated with a cube root symbol, or if it was written as a rational exponent, you can still solve that equation. So that's the concept we're going to be using with these next few. Okay, so on 54, we're going to divide by 3 first, okay, because we want to isolate that variable x with its exponent. So this is going to be x to the 3/2 power equals 125. Okay, to counteract that exponent, we are going to take both sides to the 2/3 power. So that means 25 is also taken to the 2/3 power. Okay, so this becomes x, all right, because power to a power, 3/2 times 2/3, that would be 6/6. That reduces to 1. So x equals 125 to the 2/3 power. Okay, well, if you remember back, a to the n over m power is the same thing as saying the mth root of a to the n power. So the denominator on this exponent becomes the root, and the top number, the n, the numerator becomes the exponent. So I could rewrite 125 to the cube or to the 2/3 power by doing cube root. Okay, the 3 becomes the root. The 2 becomes the exponent. So 125 squared. Okay, cube root of 125 is 5. Factor tree, 125. 5 times 25, 5 and 5. So you got 3 5s make up 125. So x is going to equal 5, but then I have to square it. So you get 25. Okay, so that's how you're going to solve an equation that has a rational exponent. Okay, let's move on to the next one. So this one, I'm going to divide by -2, both sides. That reduces. I have x to the 3/4 power equals 8. Take this, the reciprocal of 3/4 is 4/3. So take it to the 4/3 power. Okay, so since those are reciprocals, they're going to cancel each other out. They reduce to 1. So I have x equals 8 to the 4/3 power. All right, well, again, how do I rewrite that with a radical? It's going to be the cube root of 8 to the 4th power. Well, cube root of 8 is 2. And then 2 to the 4th power would be 16. Okay, let's do 56. Dividing by -2/3 is the same thing as multiplying by a -3/2. So -3/2. So x to the 1/5 is going to equal, okay, now this would be over 1. So I would have 6 over 2, or 6 divided by 2 is 3. Okay, so on this one, to get rid of that 1/5 power, the reciprocal of 1/5 is 5. So this would just be taking 3 to the 5th power. So x equals 3 to the 5th. Um, 243. Okay. All right, let's look at these next couple. So example 57. Now, since the quantity is to the 5/2 power, we're going to get rid of that exponent first. Okay, before on the previous 3, the exponent was only just for the x, so that's why we like divided by the 3 or divided by the -2. But on this one, we are going to need to do 2/5. So both sides to the 2/5 power. You now have x plus 3 equals, and it's 32 to the 2/5. Okay, well, if I think about what that means, that's the 5th root of 32 and then squared. 32 is a lot of 2's. It's actually 5 2's. So if you do a factor tree, you're going to be able to do one group of 2's. So the 5th root of 32 is 2, but then that's going to get squared. So x plus 3 equals 4. Move my 3. And I get x equals 1. All right, on 58, same thing. I need to get rid of the exponent, so I'm going to use 3/5 power. So x minus 3 equals 243 to the 3/5 power. Well, just a second ago, we saw 3 to the 5th was 243. So if I rewrite this as a radical, this is the fifth root of 243 cubed. So x minus 3 equals 3. Okay, fifth root of 243 is 3, but then that gets cubed. So that's 27. And then add 3, and x is 30. Okay, 59. Subtract 3 from both sides. X plus 3 to the 1/3 equals 4. Okay, so this time we're going to take it and we're going to cube it. Okay, cube both sides. So x plus 3, 4 cubed is 64. Subtract 3, and x is 61. Okay, one other thing I want to show you before we finish up today is your calculator. So if you pull up your calculator, and let's go back, let's go back right here to example 54. If you look at this statement right here, 125 to the 2/3 power. Well, we rewrote it using the radical. Okay, but you can also do this on your calculator. So you can do 125, you can do your caret, and it's nice because it pops up like where an exponent is. And you can do 2 divided by 3 right in that exponent. In your calculator, 2 divided by 3, it's going to understand that as 2/3. So 125 to 2/3 power, enter, and it's 25. Okay, so your calculator can handle those rational exponents. Then again, I mean, you could do the same thing, right here with your 32 the 2/5. So 32 caret to the 2 divided by 5 power, enter, and you get 4. Okay, so, but it is good to understand that that rational exponent can be rewritten as a radical and how that works. Okay, that's going to be it for today. I'll come back tomorrow. We will finish out this section of notes and practice.